Put the wet stuff on the red stuff. You no doubt heard that as a firefighter. Water covers 70% of the world's surface, and we often take it for granted. Today we're going to discuss water, how it can help, or in some circumstances, hinder your next response. I'm Grant Coffey, and this is FLIR Primed. Water. It's a versatile and unique compound made up of 2 hydrogen atoms, which is the only flammable elemental gas, and 1 oxygen atom, a potent oxidizer. We need it to live, obviously, and firefighters rely on it as their primary extinguishment tool. But what do you guys really know about water? Let's look at some of the interesting facts about this compound and find out what you actually know about water as it relates to your business. Now, these are available in our free download at FLIR.com/prime, so check it out. Like I said before, water can help or hinder you. And in its pure form, water is colorless, tasteless, and odorless. And here's what to keep in mind when responding with or to hazards associated with water. Now, in episode 6, we learned about the states of matter. Water is the only substance that exists naturally on Earth in all 3 states: solid, liquid, and gas. Now, a water molecule is polar, meaning it has opposite charges at each end, kind of like a magnet. This also causes an attraction between individual molecules, or a hydrogen bond, giving it many of the characteristics we're going to describe in this episode. Water is called the universal solvent for very good reason, because it dissolves more compounds than most other liquids. But, unlike the mantra sometimes used in the hazmat industry says, like dissolves like, it won't dissolve non-polar substances like hydrocarbon-based oils and greases. Water has a neutral pH of 7, but there's one instance where it may not be your friend. What I mean by that is when dilution is not the solution for pollution. In other words, water can wash away corrosive spills or exposures, like, for example, to your eyes, like an eye wash shower in a chemical lab. But water isn't effective in diluting a corrosive in order to change the pH to neutral. If you don't believe that, check out the demo in episode 24. It can just make the situation worse. Though a water molecule is physically lighter than air, it stays on the ground, doesn't it? Now, liquid water is about 800 times denser than air. Because of their chemical nature, individual water molecules like to stick together to make a liquid. This can change many things, but it makes water relatively heavy, about 8 1/3 pounds per gallon. So if you want to push water up into a building, say at a fire, we have to overcome about 5 pounds in downward force against us per each floor. In fact, a mere 1 inch of water spread over 1 acre of land weighs a whopping ton. A large hand line for firefighting can also deliver over a ton of water each minute. Also, water's high heat index means that it absorbs heat better than most other substances and is therefore a great extinguishing agent. A British thermal unit, or BTU, is defined by the amount of heat required to raise the temperature of 1 pound of water 1 degree Fahrenheit. What that means is 1 pound of water can actually absorb 970 BTUs, which means that every gallon of water efficiently introduced into a fire setting has the potential to absorb over 9,000 BTUs per each gallon. When it turns to steam, water expands around 1,700 times, making it indispensable as a firefighting tool. Funny thing though, it contracts when cooled, but only to about 4 degrees Celsius down to 0, or freezing, where it actually expands again. Think about that can of pop you left in the freezer for too long. Although pure water is an insulator, for example, distilled water, normal everyday tap water has dissolved compounds or minerals in it, thus making it a great conductor of electricity. Also, water is sticky. It has good cohesion and surface tension. For example, you've seen this before when water holds sand grains together at the beach to make sand really hard, like you're running on it, until you stop, wiggle your feet, and apply enough energy to nearly turn the sand to liquid and your feet sink. It's called liquefaction. It also has capillary action, can actually climb up a small tube against gravity for long distances, like in a tall tree. It's virtually incompressible, which helps us transport it through pipes to our homes and at fires, but hinders us if a valve in a closed system is shut off too quickly. thereby transmitting a damaging force back throughout the entire system, causing the clanging you sometimes hear in your pipes. We can call that water hammer. Water is inert or non-reactive, but can react violently with certain substances like earth metals, sodium, lithium, or some corrosives. Emergency response actions in and around bodies of water can present some unusual challenges, because most liquid hazmat releases can eventually find their way to a source of water, and of course we try to prevent this. But when it does happen, the very nature and behavior of water presents specific response and mitigation challenges. What I recommend is you forge interagency relationships with our on-the-water partners, like your county sheriffs, the U.S. Coast Guard, and others, that are the folks who have jurisdiction for navigable waterways. In the case of an incident that does make its way to the water, we may need equipment like boats or booms or other watercraft to access issues on the water. There are also many options for other specialized equipment that can assist in our efforts to mitigate hazmat events on the water. Water seems simple, doesn't it? But there's a lot to remember when you need to rely on water or encounter it as part of your emergency response. Again, check out the download for this episode at FLIR.com/Prime. Thanks for watching another episode of FLIR Prime.